Hello everybody, myself Nidhi Joshi, and in today's session I'm going to discuss about the greedy method, and in my session particularly I'm focusing on the Huffman coding, which is Huffman coding, which is one of the application that I had discussed in my previous video. So in today's session I'm going to discuss like what is the Huffman coding, how the algorithm work with an example, and after that we are going to see the analysis of the Huffman coding. So now we'll start with the Huffman coding. The Huffman algorithm was first developed by David Huffman when he was doing PhD from MIT. This algorithm is basically a coding techniques for encoding of the data. Such an encoded data is used in the data compression technique. So, in the Huffman coding method, the data is inputted or the data is given as the sequence of the character. Then the table of the frequency of occurrence of each character of the data is determined or built. So, after we got the table of the frequency, then the next step involved is we are creating the Huffman tree, or in short the Huffman tree is constructed from the table of frequency. After constructing the Huffman tree, we are encoding the tree of each character so that we are getting the binary encoding of the given data. As well as the Huffman coding produces the code in such a manner that no code is prefix of some other code word. That's why we are calling it a prefix code or the prefix free code. So as soon as we got the prefix code, so this technique or this approach is useful for obtaining the optimal data compression. So as I was discussing about the Huffman coding, that time I had discussed the algorithm or the Huffman coding is a coding technique. Basically it's used for the data encoding purpose, and such an encoded data is used in the data compression technique. That is the major application that we are using when we are transmitting the data from one place to another. So in the Huffman coding, it makes sure that, or with the use of the Huffman coding, it guarantees that there is no ambiguity when decoding the generated bit string. So what are steps involved? As soon as we are having the data, we are building the maintaining or building or making the frequency of occurrence of the data element. So next step involved is how we are going to build the Huffman tree. So what we are doing, first we are creating the leaf node for each unique characters, and we are building a minimum heap of all the leaf node. Second step, we are extracting the two nodes with the minimum frequency from the minimum heap. After that we are creating the internal node with a frequency equals to the sum of the two node frequencies. And the next step, that what we are doing, we are repeating this 2 and 3 step until the heap contains only one node. One node, that is nothing but that is the root node, and the remaining node is the root node and the tree is completed. So if we got the tree, so next step involves like we are doing the coding of that tree so that the characters will get the some coding. So to clear this, we are considering one example. So here we are having the character and the frequency of the occurrence of each characters. So we are having the following 6 characters and the frequency of occurrence of this character. So as soon as we got the character, the next step involved is like we are arranging in an increasing order or in the ascending order of the frequency. Here it is already arranged in the ascending order of frequency. So next is first step involved like we are building a minimum heap that contain the 6 node, where each node represent the root of the tree with a single node. So the second step is like we are extracting the 2 minimum frequency node. So the 2 minimum frequency nodes is 5 and 9. So after merging this, we got the root node is 14. Next we are extracting the 2 minimum frequency node. The 2 minimum frequency node is 12 and 13 and the root node is 25. So this node is called the leaf node or the internal node, and this is called this node C and D is the leaf node or the external node. The leaf node is also called the external node, and whereas this root node is called an internal node. Next, we are extracting the 2 minimum frequency node and we are adding a new node with the frequency. The frequency is 14, 16, so the root node is 30. Similarly, we are extracting the 2 frequency node, that is 25 and 30, and the root node is 55. So after constructing or we are getting the Huffman tree, the next step involves is like we are traversing the tree form starting from the root. We are going in the top to down fashion, maintaining an auxiliary array. While moving to the left child, we write 0 to the array. While moving to the right child, we'll write 1 to the array, or print the array when the leaf node is encountered. Or in a simple word, if we are encoding each of the above branch, so the encoding is start from the root node or we are going from top to down. If we are following the left branch, then we should encode it with 0. If we are following the right branch, we should encode it with 1. So let us clear both this point. So we are going from top to bottom, starting from the root node. If we are going towards the left node, here we are encoding it with the 0. If we are going towards the right child or the right node of the root node, that time we are encoding it with 1. So in the same way, like we had done the encoding for the character C and D, we are going in the left, that time we are encoding it with the 0. If we are going towards the right, we are encoding it with 1. So after completing this encoding, we got the characters. The codes for the following character is like this. For F, the code word is 0. For B, the code word is 1101. So if we see the previous slide, the code for F is 0. I was discussing the code for B. The code for B is 1 1 0 and then 1 1 1 0 1 1 1 0 1. In the same way, like we got the code word for the all the characters. So just now here we'll revise like what we are doing in the Huffman coding. So we are starting with the list of symbol and the frequency of occurrence of each symbol or each character in the alphabet. Second, we are selecting the two symbol with the lowest frequencies. We are adding or summing their frequencies and reducing the symbol. Fourth step is we are repeating this process, this process 2 and 3 until only the two values remain. And at last, we are creating the prefix code for each symbol from the alphabet. Like if we are traversing from top to down and assigning 0 for the left branch and assigning 1 for the right branch. Now we'll see the analysis or the time complexity of the Huffman coding. The Huffman coding requires the order of n log n time. So, in my session, I had discussed about the Huffman coding, like how we are doing the Huffman coding, why we are using the Huffman coding, how we are doing the Huffman coding. First, we are making the Huffman tree. As soon as we got the Huffman tree, we'll start doing the encoding. Starting from the root node, we are going in the top to down fashion. As soon as we got the left branch, we are encoding it with 0. As soon as we got the right branch, we are encoding it with 1. And after that, we have seen like how we are getting the coded word, why we are calling it the prefix code, how we are getting the providing the data encoding, and we are using it for the data compression purpose or data compression reason. And at last, we have seen the time complexity of the Huffman coding. That all is there in my today session. I hope you got like how we are applying the greedy method, how we are solving this Huffman coding problem using greedy method. In case if you are having any queries related to the Huffman coding, just let me know. Thank you.